Okay, everyone, for the first problem, what is the density of a substance with a mass of 0.9 grams and a volume of 1.2 milliliters? Okay, so we're going to use the density equation, D equals M over V. Okay, we have two of the variables from the problem, the mass, 0.9 grams, and the volume, 1.2 milliliters. So we divide 0.9 by 1.2 to get an answer of 0.75. Now, the units for density are grams per milliliter, mass per volume. That is those are typically the units. Sometimes grams could be a different unit from mass. Sometimes milliliters might be something different, like gallons, for example, like pounds per gallon, okay, would be one example. Okay, so 0.75 would be the answer to number one. Okay, everyone, for number two, the first part of the question says, what is the volume in milliliters of a 22-gram gold block? Gold has a density of 19.32 grams per milliliter. And what is the volume in gallons? Okay, so first we want to know the volume in milliliters of this little gold block, and then we want to know the volume in gallons for whatever reason. Okay, so we're looking for volume, and we're given the mass in grams and the density. So we can rearrange D equals M over V to V equals M over D, plug in the values for M and D, do the division, and we get 1.14 milliliters, and that is the answer for part A. Okay. For part B, we want to know the volume of this gold block, not in milliliters, but in gallons, okay? So we're going to have to convert milliliters to gallons, and we're going to use these two conversion factors. 1 gallon equals 3.785 liters, and 1 liter equals 1,000 milliliters. What we're going to do is write out 1.14 milliliters and then use the two conversion factors, making sure that the units cancel, and gallons should be the last unit left over. Okay, so here's how we would set up the problem. Okay, we write the quantity that's given, 1.14 milliliters, and then use the other two conversion factors. Okay, so this is the given quantity, and these are the conversion factors. Okay, so the given quantities always have 1 unit, and that's what we're going to start every problem in dimensional analysis with. Now, if we look at the problem, milliliters in the numerator and the denominator cancel, liters in the numerator and the denominator cancel, and we're left with 1 unit, and that's gallons. That is what we want our answer in, okay? And when we do the multiplication, the way you would do this in your calculator is take 1.14 divided by 1,000, hit equals, multiply by 3.785, hit equals, and you should get a very small number in gallons, 0.000301 gallons, okay? Okay, folks, for number 3, what is the mass in grams of 15.5 cubic centimeters, CM3 of ethanol? And then what is the mass in pounds, okay? So first in the problem, the density of ethanol is given 0.78 grams per milliliter. Now, one thing you should know, and I'm going to repeat this many times throughout the course, is this right here. 1 milliliter is the same as 1 cubic centimeter. So we can just cross off cubic centimeters and use milliliters. So now what we're going to do is we know D equals M over V. We are given the density, we're given the volume, and we can now calculate the mass by multiplying density times volume to get a mass of 12.1 grams. For the second part, what we'll need to do is convert grams to pounds. We're going to use these two conversion factors right here, 2.205 pounds and 1 kilogram, and 1 kilogram equals 1,000 grams. We're going to start with 12.1, and we're going to set up the problem so that the units cancel and our final unit left over is pounds. So we would write 12.1 grams times 1 kilogram equals 1 kilogram over 1,000 grams times 2.205 over 1, and there is our answer. Okay, now when we set this up, okay, take a look. Grams and grams in the numerator and the denominator cancel. Kilograms and kilograms in the numerator and the denominator cancel. And the only unit left over is pounds. Okay? The way I would put this into my calculator, you can skip any operation that just has a 1 there. So this would be 12.1 divided by 1,000, hit equals, times 2.205, hit equals, and you should get that answer. Okay, now one thing when you are setting up these conversion problems, whenever you're setting up dimensional analysis or unit conversion problems, the conversion factors can be written in two different ways. 1 kilogram equals 2.205 pounds, or 2.205 pounds in 1 kilogram. So they say the exact same thing. 1 kilogram equals 2.205 pounds. 2.205 pounds equals 1 kilogram. For any conversion factor, you can switch the numerator and the denominator as you need. Okay, so sometimes you'll need to use it like this, sometimes you'll need to use it like this. It all depends on what you're doing in the problem. Okay, same thing with the pounds and kilograms. Any conversion factor, anytime you have something equals something else, you can always switch the numerator and the denominator however you need to in the problem. Okay?